Hi everyone, in this video I will be showing an experiment I am doing, and this experiment was in my mind for a long time, but I did not had time to try it. So now I am doing it, and this is 220 liters or about 60 gallons I think, or 50 gallons tank made from thick plastic, and currently it's filled with water. As you can see at the top, it's all filled with water. I have attached a ball valve over here, and this is not a permanent fix, but I did it. And the thing is that this in here there is a water heater element inside, which is heating up by solar power. The element is dipped in water, as you can see, and by this cap it's held so that this would not submerge in water completely, because there is risk of electric current coming into water. And the stick you are seeing here is because the element is on the upper side of the tank, and when water heats up it remains on the upper side, because I think it's sort of some concept as same as that hot air rises and cold air remains low. So this stick is for about after 20 to 30 minutes later I will just do this sort of thing. And currently I cannot do a good job of it because I am holding camera in one hand. So I will just stir it up, and hopefully the cold and hot water mixes together. And so the thing is, this is the water heating element you are seeing is about rated for about 1500 watts, and it's running. I can adjust this because this setup is running on a variable frequency drive, VFD. I am going to show you. This is the wire going here, and you may be wondering what this machine is. It is chaff cutter, fodder cutter for our goats you are seeing there, so don't worry about that. This is our clover. We feed it into this by lowering this, and these are the blades which cut the grass like that. So there is that. So this is our VFD, or variable frequency drive. We can adjust its frequency by this potentiometer over here, and currently this is running at 40 Hertz. By lowering the frequency I can lower the wattage of the heating element inside water, and if it goes maximum to about 50 Hertz, which is typical, and currently it's adjusted to 240 volts at 50 Hertz. So the relationship is linear, and currently it's running at about 1700 watts of power, and the power is measured in DC, so there is some losses happening over here. It's not 100% efficient in converting DC electricity to AC. So I may show you the voltage. It's currently 540 volts in DC. It's about 1250 volt panels in series, and it's adjusted. It's not an MPPT. We have selected a setting that works in our area, where we could attain maximum frequency of three-phase motor. So by lowering the voltage value, we can extract more current, and vice versa. so it's 540 volts, and the voltage going to the AC heating element is about 200 volt AC. It's drawing about its value is not correct because this is for 3-phase motor and it just does not work over here. And this is RPM. If running that was on 3-phase motor, there would be 1200 RPM in a 4-pole motor, which has total RPM of 1500, or the frequency in our area is 50 hertz, 240 volts. So this is the frequency now. And specific heat capacity of water is in this container I have calculated. It's about if we raise the temperature from 26 degrees Celsius to about 90 degrees Celsius, which is below the boiling point of water usually, which is 100 degrees Celsius. So there will be around, it will consume about 16 kilowatt hours of electricity to raise the temperature from 26 degrees Celsius to around 90 degrees Celsius of this volume. This is around 220 liters of water in this barrel over here. So the thing is, I am trying to build a thermal battery. So currently it's winter, we hit, and our house is not insulated, so it gets pretty chilly inside during night time. So net metering is not available in our area. So I am just trying to figure out, maybe we can use this heated water, which is heated during the daytime with solar power, which is free, and we don't have any other use for it. The main purpose is for irrigation of our land, and the winter we have to irrigate every 10 to 15 days, so there is a lot of free days in between. And the other possible, and I will use this hot water with some sort of heat exchanger to heat up our home. So at least our room, I will say, sorry, because it's not quite possible to heat our entire house with this small of a container. But the thing is, the water holds lots of water has a lot higher heat capacity than other materials, and this is very easy also. It's very abundant, and the plastic, I hope, will not be too damaged by around 90 degrees Celsius water. I think this plastic can handle that easily, but this is an experiment. I have not tried this before, so please don't try this at home, because fussing around with electricity or playing around with it can be very dangerous, possibly even fatal. So please don't try this at home unless you know what you are doing. This is a sketchy setup, and this is not permanent. This is just for an experiment I am conducting to show whether it is feasible actually or not. So, and the other use is that there are our goats, and they shelter in this room, in barn type room, in night time. They also get pretty so I am hoping to at least do some kind of setup for them also, because in winter time goats don't like cold very much. They are not very tolerant. They get sick all the time due to extreme cold. And in our area there is not an extremely low temperature, but it gets around 2 to 3 degrees Celsius at night time, lowest value in winter. So, and the other thing, the main thing is that the barn or our rooms are not insulated. This is only made up of bricks, and they are not good insulators. And there are lots of these holes here which have been covered by rice straw so that no cold air gets inside this at night time. So these are our solar panels, which currently are very dirty, and because we usually don't clean them because there is not use of them. We currently don't use them, and so we often just don't clean it, and when we use them we just clean them with water, and they are clean. Those are also solar panels over there. You are seeing this is an uplift stand which is also a movable. It's a manual stand, a manual movable structure, and it can move from east side to west side. This is our pasture, clover pasture, which we use to feed our goats, our livestock, and we also sell them that. As you can see, there is a person manually reaping with sickle. The temperature of this water is 38.5 degrees Celsius. Let me show you. I hope you can see that 38 on the lower side of this clinical thermometer, 38.5 degrees Celsius.